Hey everyone, towards the end of the last video, I said that there is a problem with the orientation warping implementation that had to do with the stop transitions. I was wrong, correct but also wrong. Fixing that problem, well, I attempted to fix that problem by moving these stop transitions, and, well, things didn't really work out. I spent a long time debugging, testing, trying to get things to work, but I just couldn't get orientation warping figured out in the limited time frame that I had. This video and the next one I'm actually making pretty much inside of one weekend, because I'm going to be on a trip out of state for a week and I don't want these videos to be delayed. And I didn't have enough time to really solve the orientation warping and work towards really trying to figure that out, so I'm putting that on the back burner. And in this video I'm going to be stripping out the multi-directional functionality, and I'm going to be changing some settings in the character movement component so that the character walks towards the so the character faces towards their velocity. If you're going left, the character is using the forward animation going left. If you're going backward towards the camera, your character is running towards the camera. And that'll be a temporary change so that we can continue forward with our start transitions, which I will be implementing into the project in this video. So with all of that out of the way, let's get into it. With that lengthy introduction out of the way, let's get straight into things. I'm first going to open up my distance matching character, and I'm going to change some of these variables. In the character movement component, we're going to want to check use separate braking friction, set that braking friction to 1. And we're doing this because with ground friction set to such a low value down here, that feels a whole lot like the character is sliding around on ice when we're not strafing and just walking forward and turning around and using that method of locomotion. It's a whole lot easier to tell. So we're going to set this back to 8, and we'll just switch over to using this braking friction when we are stopping. And because we're switching over to use a different variable when we're stopping, we're no longer using ground friction in our prediction. Instead, we're going to use braking friction. So I can compile and save, and now if I play, it still takes us the same amount of time to stop, but we're not sliding around like we were before. And now we're going to go over to the animation blueprint, and we are going to make the big changes that I talked about. So last video I added this on and I forgot to connect this up, and if you connect it up it causes some issues, and that's not why I'm getting rid of this. I'm recording this before I record the intro, so I might be saying something that I've already said before in the intro, but the orientation warping is proving to be a problem, not an unsolvable one, as I have a clear-cut path figured out in my mind to solve it. The problem just is, the problem here is that I'm going to be going out of state, and I'm making these videos in advance, and I'm on a very limited time frame, so I don't have the time that I'd usually have to figure something like that out. So instead I'm making some changes so that we can skip orientation warping and come back to it once I have it sorted out. So I'm deleting the duplicated blueprint logic here, and now I'm going to open up the anim graph. I'm going to go into Locomotion, and I'm going to change the name of the Locomotion state to start. Starting, actually. And I'm going to add a state, and I'm going to name it running. And now this multi-directional logic that I put together in the last video, we're not going to use this because because we are getting rid of strafing and going in any other direction other than forward in the direction of movement. So we're just gonna disconnect this for now. I'm gonna plug starting into running, and I'm going to plug running into stopping. And now I'm going to copy the logic. I'm just going to cut it from starting to stopping, and I'm going to paste it into running to stopping. I'm going to delete the... Actually, I'm going to keep the code that goes from starting to stopping, because logically, you should be able to stop while you're starting. Now, we're not going to worry about starting to running just yet. But inside of running, I am going to play in run F anim. And inside of starting, I'm going to play in run start F anim. And there are two run start animations in the project in the animation file you downloaded. Right now we're using this first version. We need to get our starting animation ready to be used. So we're going to go to our animations, we're going to open up in run start anim, and we're going to add our BPAM distance curve start modifier. We're also going to make sure that enable root motion is true. We're going to save. We're going to go back to our animation blueprint. And we are going to actually copy some of this logic here. This here. I'm going to duplicate it. I'm going to change, since I didn't duplicate this because there's no right up or left up for starting, I'm going to get in run start F anim. Make sure you click on the right one. The other one doesn't have any curves set up, and it'll give you some weird results. And I spent a good 10 minutes trying to figure out what was wrong with my logic before I recorded this in my testing project where I work on this ahead of time, ahead of the videos, and I just had the wrong animation selected, so just make sure you choose the right starting animation. Now, this logic we actually need to change. We don't need to multiply this by -1, and we need a different variable, a starting location. So now we're going to calculate that variable inside of our distance matching character. Now, we only want to set the starting location when the character is starting, when there's input on the keyboard or from a controller to begin moving. So, I'm going to get a sequence. Then 0 is going to be plugged into our branch where we're checking for stopped and doing our stop prediction. I'm plugging the sequence itself into our first sequence, which is plugged into event tick. And then 1, I am bringing down into a branch. And now we're going to determine if the character has began moving with these booleans here. There's other ways to do it. And these are already right here, and all I have to do is drag out from stopped, get a not, get an and, plug in has moved to it, and plug that into the branch. And you could use velocity if you wanted to, acceleration, input values. There's different ways to do it, but I have my variables sitting there, easy to drag, and that'll work for the time being. And I also want to reiterate, so I'm getting a do once, and I also want to reiterate that I am not putting this together in this video series with the intention that it's the best way to do distance matching, the most optimized way to do distance matching, the most efficient way to do distance matching. It is not any of those. I'm not trying to make it any of those. If I was, I would be doing this off of Event Tick. There are ways to optimize this much further than I have. There will be ways to optimize it much further than I have still when I consider the series to be done. This is a starting step towards having a really good distance matching system. This series isn't meant to tell you how to get there 100% of the way with the best distance matching system you can make. I'm trying to make it an easy to follow distance matching system, and I also want to be able to make these videos very regularly while also still having time to work on other projects. And to do that, I can't spend a whole lot of time constantly working on optimizations for the logic here. And so that is, I just want to make that very clear, that there's always going to be ways to optimize. Not sure why I dragged that out. There's always going to be ways to optimize it further. So we're going to get our actor location. Going to plug this into start. I'm sorry. No, we're going to create a variable. There is no variable to plug it into yet. We need our start location variable. And now I'm going to copy this draw debug sphere from our stop prediction. I'm going to change the color to red, and I'm going to just plug in start location to it. And now if we play, things are going to be a bit broken, but you can see that there's a red sphere, and you can see that it plays our start animation. And so that's good. We have our start prediction, but we need to go into our starting state, and we need to change this play and run start F anim. And we need to convert it to a single frame animation, and we need to now set our variable. And we could set curve time, and that would probably be the best way to do it, would be to put some extra logic here, but in the spirit of making this easy to follow and keeping it simple and choosing some form of simplicity over optimization, I'm going to rename this variable to stop time and create a start time variable. And for those of you who want a super complete tutorial, something that is more of a how to make a super optimized, versatile animation system, I will be making that sort of tutorial inside of Unreal Engine 5 at some point in the future, closer towards either the end of this year or the beginning of next year, probably right around when probably sometime in the beginning of next year once Unreal Engine 5 launches and everything is there in the first version. I'm going to be building an animation system. Maybe I'll start streaming myself building that system. Maybe all the way back to now. That could make for some interesting streams. And yeah, I think I will do that. And I'm gone on a bit of a rant in this video, but so I apologize for that. So I have this code right here. I just added it here. I changed curve time to stop time. I created start time. And I have character going into get actor location. and stop location, which we're going to change in a moment here, into distance, and distance into get curve time. And I have in run start f_anim, not the second other version of the animation, the version 2 of the animation, and that's going into start time here. So we have the start time variable, and we're going to plug it into our start state. Now we need the logic for transitioning from starting to running, and you might think, well, I can just tick automatic rule based on sequence player in state, and that would work if we're just playing the animation back. It doesn't if we are using an evaluate node like we are here. So instead, it's a little bit hacky, and I came up with it a couple minutes ago before I started recording this video, but it works perfectly fine, I think. So, and if you're clicking around it, I'm pulling it up on my other screen here, what I did. We're going to go back to our event graph. We're going to copy our get curve time, for starting. Actually, we're going to copy that. We're going to paste that in here. We're going to set the value to something crazy like 10,000. And so that's just going to give us the end of our animation, because we don't travel that far. The closest thing to it is the longest distance we've traveled, this 102.793 units. That's closest to 10,000. So it's going to give us the animation time from there. And now we can compare start time with the time that's the end of our animation. And if they match, we can enter a transition. And so that is how we're doing it. And now let's quickly go over the timing between the transitions here. For starting to running, it should be 0. To go from idle to starting, it should be 0. Running to stopping should be 0.05. And stopping to idle should be 0.05. Starting to stopping should also be 0.05. Now I can compile this, and I almost forgot. Since we're pulling strafing and all that out for the time being temporarily, I'm going to go into the details panel for a character movement component, and I'm going to search up orientation. I'm going to tick orient rotation to movement. I'm going to go and just click self up here, up top, and I'm going to type in yaw, and I'm going to uncheck use controller rotation yaw. Now, if we play, I'm going to ignore that this isn't working, and our character moves in the direction that our character is facing. Now, let's take a look at this. So something isn't working. That is because we're using our stop location still. I actually didn't get the variable. I made the variable, but I didn't pull it into our animation blueprint. So let's do that. Let's get our start location, and let's promote it to a variable. And we'll set it between stop location and velocity. Now, we can plug in start location, compile, play, and it's still not giving us a value, which is a little strange. We need to make sure uniform indexable is selected as our curve compression type. So now if we play, it works. So I'm noticing a little issue here. Sometimes it's working, sometimes it isn't. And that's not something I picked up on a couple minutes ago. 23 minutes ago, wow, okay. Before, when I started recording, or when I tested this before I started recording. Okay, everyone, so there's a little problem, and I know how to fix it, and it's with our hacky logic to go from starting to running. We're not resetting start time when we are getting our, once we're past starting, we're not resetting our start time. So it's staying at that high value, and we go back into it, and so sometimes things work out and other times they do not. So how do we fix that? We pull our code right here with our branch and do once and all of that. Actually, yes, we pull all of our code without our do once. We paste that into here. We connect set stop time to our branch and our branch true to start time. And so what this is doing, we also didn't recognize has moved, so let's drag that over. So if stopped is not true, so if we are moving and we have, and stopped can also be not true and we haven't moved yet, so we have this has moved too. So if that is true, then that means we're just starting. So now, when we're stopping, which is false, we've stopped, we need to set our start time to 0. And now, every time we start walking, we use our starting animation with distance matching. And now, it looks a bit strange if we change directions. Our character does this slow turnaround. And I think that's going to be the topic of the next video, fixing it. I think a foot locking solution might be the best option, where we lock the foot as we turn and then unlock it as the foot's getting ready to be lifted up. This could also be solved with more starting animations, and that's how it's usually solved. I don't have those here, and I don't want to pressure Ryan to make them when he has plenty of other animations and other things to work on for his own game. So we're going to make do with a little bit of foot locking hackery. Alright everyone, our character can now start, and because I recorded the next video before I recorded this outro, I can tell you with confidence that the foot locking is not what is coming next. All the effort to create a good system isn't worth the result. Eventually I'm just going to get some new starting animations worked in, or not if we go back to orientation warping. So instead, in the next video, we're going to be focusing completely on slope warping, as well as addressing a bug with a fix suggested by someone in the Discord server for stopping on slopes. If you enjoyed the video, give it a like, and if you're enjoying the series and want to see when the next one's out, be sure to subscribe to the channel and hit the notification bell. Thank you for watching, and I'll see you in the next video.